Good afternoon, everyone. We are the sdgary team. We apologize that we cannot arrive at MICC AI on time, and appreciate that the CPM PAS organizer to allow us presenting the math using a recorded slide. I am Shangwei Chen from the National Taiwan University of Science and Technology. The title of the presentation is Automatic Classification of Brain Tumor Types with Histophysiology Images. The CPM RadPath 2019 database consists of 221 certified and 73 subjects for training, validation, and testing stages respectively. For local evaluation, we select 191 datasets for training and 30 for testing. From each dataset, we have 3D whole brain MRI, including T1, T1C, T2, and FLAIR images, and a whole slide histography imaging. In addition to the MRI and the whole slide images, we also have a CSV file indicating the tumor. The primary aim of this challenge is to classify the subject into 3 tumor categories, type A, O, and G, using MRI and/or the whole slide imaging. Our initial idea for this challenge was to perform an in-symbol prediction of TIF and MRI. For MRI, we used the segmentation model obtained from the previous breast challenge to predict the tumor region. Then we produced radiomics from all MRI contrasts and trained a machine learning model with the radiomics. For the whole slide images, we trained a single model using the cropped batches of the TIF imaging. The basic idea for the in-symbol prediction is to combine the probability of the classification using both methods. However, until the end of the challenge, our best results were obtained from the TIF-only method. The MRI radiomic method didn't help on the classification accuracy. Therefore, let me focus on TIF-only method. First, we split the TIF image into small batches with a 1024 by 1024 metric. Because we use the model obtained from the winning model of the ImageNet challenge, we have to modify the batches to match the specification of those models. Therefore, we resize them into batches with a metric size of 224 by 224 and converted the channels from RGB alpha to RGB. To exclude the blank region of the whole slide image, we calculate the sum of standard deviation of RGB channels of each batch and exclude the ones with the values less than a threshold. The batch extraction produced is the most time-consuming part of this method. Then we use 2 deep learning models, VGG16 and ResNet-50, to extract the features from images. The model weights are based on the winning model of the ImageNet challenge. For each image, we extract 4096 features from the FC2 layer of VGG16 and 2048 features from the average pool layer of ResNet-50. The feature extraction step converts a TIFF file of each patient into a feature metric with a size of n by 4096 for VGG16 or n by 2048 for ResNet-50. N is the amount of obtained batches. It is desirable to collect only batches that provide information to distinguish tumor type of patients. However, the ROIs of tumors were not provided in this challenge. We came up with an unsupervised clustering method to distribute the batches into several groups. The next problem is, how do we choose a right group which could include the most tumor types? Our solution is to select the group by evaluating the classification performance of each group. First, we use the k-means with cluster size 1 to 6 and the 2048 or 4096 image features. Then we train classification models using the light GBM for each group and evaluate the prediction accuracy of all the models. This table lists the model performance obtained in the VGG16 features with a standard deviation threshold of 100. Notice that the values of this table are the performance per whole slide image, not per batch. The column named split 2 to split 6 represent the result obtained from k-means with numbers of clusters equal to 2 to 6. In our result, the microaverage of split 6 model with the cluster label 3 had the best performance. It's supposed that the unsupervised algorithm identifies a group of batches that is useful for tumor classification. This table represents the classification performance per batch of the batch group obtained from k-means with 6 clusters. We try a different combination of features, such as 4096 feature of VGG16, 2048 features of ResNet50, and 6044 features combining both VGG16 and ResNet50. The combination do not present prominent difference. In the training set, we have fewer type O cases. It could be the reason that the F1 scores are lower than those of type G and type A. According to the local test and validation result, our final result is obtained by k-means with 6 clusters, VGG16 model with 4096 features. The threshold to exclude the blank image is 50. We didn't use MRI radiomics features. We calculate the average probability of all batches, extract from each whole slide image to determine the final tumor prediction. If you have further questions, please don't hesitate to contact me by email. Thank you.